Okay, in this example it says, what is the coefficient of static friction if 10 newtons of force is required to move a 2 kilogram object on a flat surface? So let's go ahead and draw this out real quick. You have a surface that's flat, you have an object that's on there, and that has a mass of 2 kilograms, and that you know that you have to exert a force of 10 newtons just to make the object move. In other words, you have to have 10 newtons of force to overcome the static frictional force. So what I can say then is that the given information is that 10 newtons represents the static frictional force. I also have the mass as being 2 kilograms. Okay, so now I'm trying to solve for the coefficient of static friction, or the frictional force is equal to the coefficient of friction times the normal force. Remember, once again, since this is a flat surface, you can say that Fn equals Fg, or what that simplifies to is the static friction is equal to the coefficient of friction times mass times gravity. So now we plug our numbers in and we can say, okay, I have 10 equals what I'm trying to solve for, and then 2 times 9.8. So what I do is I'm going to start to isolate US, and how I'm going to do that is I'm going to divide both sides by 19.6. Okay, when I divide both sides by 19.6, I go to my calculator, I say 10 divided by 19.6, and it gives me a coefficient of friction of 0.51. Now, the units for static friction, there actually are no units, and we can show this to you. So right here, you have a force, and this force is measured in newtons. Okay? When we divide it, we're dividing it by a mass times a gravity, or kilogram meters per second squared. Remember, a kilogram meter per second squared is the definition of a newton. So this actually cancels out, and there's no units left. This coefficient is just a ratio, so that it is correct in saying that there are no units.